Today we are going to use the converse of the Pythagorean theorem. You're going to look for and make use of structure when you're using the converse of the Pythagorean theorem to solve problems. So we're going to use the structure of the theorem of the a squared plus b squared equals c squared when we are solving various problems. So go ahead and take a moment to think to yourself, if you're given three sides of a triangle, side lengths of a triangle, how can you tell if they create a right triangle? So you can assume that this will involve Pythagorean theorem, considering the whole section is about the converse of the Pythagorean theorem. But what exactly about it would tell you whether or not a triangle is a right triangle? It would be a right triangle if a squared plus b squared equals c squared. So let's go ahead and just take a moment to think about the Pythagorean theorem. So it states that given a right triangle, the sum of the squares of the legs of that triangle is equal to the square of its hypotenuse. So in other words, given a right triangle, the sum of the squares of the legs, so the legs are a and b, the squares of the legs are a squared and b squared, the sum of the squares of the legs are a squared plus b squared, and that's equal to the square of its hypotenuse. The hypotenuse is c, and then the square of it is c squared. Okay, so this is the Pythagorean theorem. So what's the converse of the Pythagorean theorem? Well, in order to know that, we need to figure out what the converse of something is. So that's like taking it and making it backwards. So saying the last thing first and then the first thing last. So instead of saying that we know it's a right triangle, so then we know that a squared plus b squared equals c squared, the converse says if we know that a squared plus b squared equals c squared, then we know it's a right triangle. Okay, so let's go ahead and use this to answer these following problems. So let's go ahead and state whether or not the side lengths that are given to us create a right triangle. So starting just with 2, 3, and 5. We have three side lengths, and we need to figure out if they create a right triangle. So we're going to use this converse of the Pythagorean theorem that says if a squared plus b squared equals c squared, then it's a right triangle. So we need to take 2, 3, and 5 and put it into that equation, and that'll tell us if it's a right triangle. If it does equal, then it's a right triangle, and if it does not equal, then it's not a right triangle. Okay, so in order to put these numbers in this equation, we need to figure out what our c is. This one, it's pretty easy to look at that and notice that 5 is the largest number, so 5 is going to be the c. So let's go ahead and write this out. 2 squared plus 3 squared equals 5 squared. And then we can work this out. 2 squared is 4, 3 squared is 9, 5 squared is 25, 4 plus 9 is 13, and that does not equal 25. So this is not a right triangle. Okay, let's go ahead and move on to 6, 8, and 10. Once again, the first thing I need to do is recognize that I have 3 side lengths for a triangle, and so I'm going to use the Pythagorean theorem. I'm going to look at these numbers and notice that 10 is the largest, so 10 is my C. So I'll go ahead and write 6 squared plus 8 squared equals 10 squared. And now I can work through this and solve it. 6 squared is 36, 8 squared is 64, and 10 squared is 100. 36 plus 64 is 100, and 100 does equal 100. So, this is a right triangle. All right, let's try one more. 2 square root of 6 and square root of 10. So when you have numbers like this, you need to make sure you're really paying attention to what the value of these numbers are. Don't just look at the number inside of that square root sign and say, oh, square root of 10 is the largest. You need to look at these numbers and figure out exactly what they equal, because the square root number isn't always going to be the largest. So looking at these and estimating what they are, square root of 6 is going to be 2 point something, because the square root of 6 is between square root of 4, which is 2, and square root of 9, which is 3. Square root of 10 is going to be 3 point something, because it's between square root of 9, which is 3, and square root of 16, which is 4. So in this case, square root of 10 is the largest, but that's not always going to be the case. So make sure you're really careful when you're writing your equations. If you choose the wrong C, your equation is not going to end up equaling, even if it is a right triangle. It's crucial that you use the largest side length as your C in order to check if it is a right triangle. So let's go ahead and put these into the Pythagorean theorem. So 2 squared plus the square root of 6 squared equals the square root of 10 squared. Make sure you put in the numbers that are given to you. So if you're given square roots, put those into this equation, because watch what happens as we work through this. 2 squared is 4. Square roots and squares cancel each other out. They're opposite operations, so this just leaves me with 6. Once again, my square root and my square cancel out, and so that just leaves me with 10. So I have 4 plus 6 is 10. 10 does equal 10. So I can go ahead and say this is a right triangle. That's all there is to this section. So go ahead and get going on your homework. It is due on Monday in class if you don't have it done already. And make sure you let me know if you have any questions on these problems.